One animated model natively supported by ComfyUI with official workflow updates. Previously, we were all using KJ streams, so let's see how the official process differs from what we've seen here. In general, I think the results would be better. An update to the DG Prisma model special version that can directly generate images in pixel space is incredibly amazing. Doing this would greatly increase our performance requirements. Then let's take a look at the workflow. I'm using the largest online ComfyUI platform, RunningHub. As for quick startup, we need to set the resolution, frame rate, low reference images, and video. Then you can run it directly. Then we'll look at the details of model loading. The large model uses a BF16 precision version. Here we're using an acceleration model called Relight LoRA with a speedup ratio of 2.1. There's no custom configuration here. It's completely aligned with the official settings. Forward and backward prompts are almost always ineffective or nearly ineffective whenever we use an accelerated model. The next section is about extracting control videos for the Animate model, which includes eye reference and pose reference, as well as image references. What about the image references? Earlier, we have already loaded the original video to extract facial features and body posture. The official pipeline uses DW Open Pose for both pose and facial extraction. For the face, select to enable only the face. Open up your body and hands for posture. Finally, this is what we got after editing. So here, the difference here from KJ is that the input for facial video comes directly from the original video, with KJ using a cropped face from the original footage as the video input. The difference lies in the fact that it's not the extracted image. I think the official approach is reasonable because in previous processes, we found that cutting off the facial video improves reference similarity. So what kind of form does the control video for the input facial video take? People tend to prefer this kind. The more scattered it is, the less control we have over its facial expressions. Of course, tie strength is stronger than open pose. There is a node that can extract posture, facial features, and mass preprocessing in one go, which is also possible. It just means that the node updates aren't very complete, and there are still many errors. In production, it's mainly used for the later mask extraction, which uses the SAM2 video mode. For single-person use, it's almost fine and doesn't need much consideration. But when multiple people are involved, it starts to have issues. We'll need to refine it a bit more and wait for the node update. Finally, let's take a look at some additional input and output points in the One-Animate to video node. The first one is continue motion, which is an input. In the following loop, it is directly used. This connects to the result from the upper group, which is why the lower half loop can be constructed. 3 output points, and the task of these 2 output points is to cut off the first few frames of the generated video because the first few frames usually don't look very good. So what I've done here is generate 77 frames, and I've cut off the first 4 frames automatically. This is why loops can be built. It serves as an output here, but acts as an input in the lower half loop. Then it will loop back to generate again. So this is the result from the first generation. Overall, evaluating the first output result, the color is reasonable, the similarity is acceptable, and even without adjusting the model, we've already achieved a relatively good outcome here. Navigate to Running Harbor's AI or click the link in the introduction to register and get 120 HP. Log in daily to receive an additional 100 points. The corresponding AI workflow and one-click start AI applications. They have been deployed online in sync and can be run and tested online. Then we look at the construction of the following loop, which has 2 input items, V61 and V62. This cycle mainly relies on the 2 points I just introduced, and it is carried out through this process to form a loop. Why is this process considered semi-automated? Because in the official setting here, if you want to perform a loop longer than 200 frames, we need to extract or prepare all of them in this group. Video, faces, and posture, and previously our loop could also prepare this part in batches on its own. In reality, there's really no difference at all. The number of cycles, for example, if we have 200 frames and the upper part has gone through 77 frames, then we can go through 2 more times below, making it over 200 frames in total. If the number of generated frames exceeds our input image, the final result will appear completely still. So if you want to run this process normally, we definitely recommend first doing the initial generation and then proceeding with the iterative generation. Finally, let's take a look at this new supported Chroma model from the official side. So it completely generates images within this pixel space. For example, in the version 0.2 model with dimensions of 1024 by 1024, the memory usage when entering the sampler approaches over 30 GB. In such cases, we need to rely on VAEs for encoding or decoding. The characteristic of performing such inference at the K-sampler allows real-time preview of our generated results. Then I believe this is a variant model with research. And these experimental models, trying to break away from the traditional latent plus VAE approach, really aim for the ultimate quality. So most of the time, this channel shares open source models and projects, but closed source models are where RunningHub really shines. He brought down the prices of many popular models, such as Video, Kaling, and Wanshang. Some specifications were even lower than the official published prices. The more you use it, the more you'll realize that saving up bit by bit really saves money in the long run.